In this video, we're going to look at linear transformations of roots. So this is when you've got a polynomial which has particular roots, and then you want to find what a polynomial is whenever it has a different set of roots, but the different set of roots have to be linked. So for example, if alpha, beta, gamma were your original roots, then the new roots could be alpha plus 2, beta plus 2, gamma plus 2. So the linear transformation is you just take the original roots and you add 2. But it's not just quite as simple as just doing that. And likewise here, you had 3 alpha, 3 beta, 3 gamma. So you've just multiplied your original roots, alpha, beta, gamma, by 3. Okay, it could also be a combination of those. So it could maybe be 3 alpha plus 2 would be a root, 3 gamma, 3 beta plus 2, and 3 gamma plus 2 would be a root as well. Okay, we're going to look now at an example of this, a couple of methods to do this, and we'll see how we go. Okay, I have the bulk of the solution written in here, so I'm just going to really be talking through how we do this. So in this one, it says the cubic equation, x cubed minus 2x squared plus 3x minus 4 equals 0 has roots alpha, beta, gamma. Find the equation of a polynomial with roots 2 alpha, 2 beta, 2 gamma. Okay, so our original polynomial, I've just written that down again. Our original polynomial, x cubed minus 2x squared plus 3x minus 4, has roots alpha, beta, gamma. So alpha plus beta plus gamma, that's the sum of the roots, equals 2. Where that comes from, remember your alpha, beta plus gamma, your sum of your roots, that is equal to minus b over a. So that's where that comes from. So b was minus 2, a was 1, so minus 2 is just 2 over 1, which is 2 over 1, so 2. Okay, this is the sum of the pairs of the roots. So the sum of the pairs of roots, remember it was c over a. So c was 3 here, a was 1, so 3 over 1, which is just 3. And this is the sum of the products of the roots, I should say. So it was minus d over a. So that's where that comes from. So if now we wanted to have in a question, look, it said it wanted roots 2 alpha, 2 beta, 2 gamma. So if we look at those, 2 alpha, 2 beta, 2 gamma, if you add those all up, you're going to get it's going to be 2 times, you could factorize the 2 outside that, and it will be 2 upon alpha plus beta plus gamma. So it's 2 upon whatever alpha plus beta plus gamma was, and we set up here it was 2, so 2 times 2, so it is 4. So this now is equivalent to my new minus b over a. So the easy way to do this is always make the a equal to 1. So if a equals 1, then you just have minus b is equal to 4. Which means b itself is equal to minus 4. So we're basically, it seems like we're halfway there because we've got 2 of our things. We've our coefficient a, we've our coefficient b. So we're doing well already. We've got 2 of these things. Okay, the next thing was looking at the pairs. So the pairs, remember, were alpha, beta, original pairs I should say, were alpha, beta plus alpha, gamma plus beta, gamma. But now they're going to be 2 alpha upon 2 beta, 2 alpha upon 2 gamma, 2 beta upon 2 gamma. So really, here you can imagine you could pull out a 4. So that's going to be 4 upon alpha beta, 4 upon alpha gamma, and 4 upon beta gamma, or really just 4 upon alpha beta plus alpha gamma plus beta gamma, which is equal to 12. So that is your original, that's now your new thing, your sum of the pairs, I should say. So that means 12 is equal to c over a. Remember we had said a was equal to 1. That means your c is equal to 12. Okay, the only thing we're left to do is find our d. So we found d, remember from the original thing, it was the products over here. So we're going to be looking at it again. So products of our roots, remember our roots were 2 alpha, 2 beta, 2 gamma. So product those, you're going to get 8 times alpha, beta, gamma. And alpha, beta, gamma from earlier on we said was equal to 4. So that's just 8 times 4, which is 32. So that means, again, remember your a is 1. So that means minus d over a is equal to 32. And a is 1. So that's just minus d is equal to 32, or d is equal to minus 32. So the equation, that's my a, x cubed term, my b, x squared term, my c, x term, and my d term. So when you put them all in, write in what your coefficients worked out to be, you'll have x cubed minus 4x squared plus 12x minus 32 equals 0. Okay, so we're going to look now, same question. We're going to look just at a second method to do this. So remember we had the original polynomial, which had roots alpha, beta, gamma, and we had to find the equation of the polynomial with new roots, 2 alpha, 2 beta, 2 gamma. So the linear transformation was just multiplying by 2. So the method 2 that we're going to use, this is a much better method than the first method, but there will be times that you have to use the first method. So you can only use this method 2 if it's definitely a linear transformation. This first method you did here, method 1, works even if it's not a linear transformation. But definitely the method 2 is the one we want to use. Okay, so we're going to have a look at it now. So method 2, remember the linear transformation was just multiply your original roots by 2. So we're going to let w equal to x. That means you could let this be equal to anything at all, and you'll see at the end it'll be changing it back to x, which is a bit weird, but we'll see. Okay, so w equals 2x, therefore x is equal to w over 2. And then I'm going to just substitute into x cubed minus 2x squared plus 3x minus 4. So everywhere I see x, you replace it with w over 2. W over 2 all cubed would be w cubed over 8. W over 2 all squared would be w squared over 4. Then multiply by minus 2 gives you minus w squared over 2. And 3 times w over 2 is just 3w over 2, and then minus 4. So you've got this ugly looking equation, which we by now know how to tidy this up very nicely and very easily, which is just multiplying by 8. So multiplying by 8 gives you w cubed minus 4w squared plus 12w minus 32 equals 0. And then just for niceness, I have just written that again in terms of my x. So x cubed minus 4x squared plus 12x minus 32 is the new equation, and that's it. Okay, looking back at part B, we had the original cubic equation, which had roots alpha, beta plus gamma. We now want to find what the equation would be if the roots were alpha plus 3, beta plus 3, alpha plus 3, beta plus 3, gamma plus 3. So we're going to look at that now. Okay, so written equation again, and then I've called that equation 1 because I'll be referring back to that. And my sum of the roots, my new roots are alpha plus 3, beta plus 3 and gamma plus 3. So I've got all the working out from earlier on. From part A, I've worked out what my original sums were, original sum of pairs were, and original products were. So we don't want to have to go through all that again. So refer back to that when we need to. So these are for my new roots. Alpha plus 3, beta plus 3, gamma plus 3 is just alpha plus beta plus gamma plus 9. And we know from earlier on, alpha plus beta plus gamma is equal to 2. So this whole thing is just 2 plus 9, which is 11. So remember the sum of the roots is minus b over a. So minus b over a is equal to 11. And again, we let a equal to 1. Therefore, minus b is equal to 11, or b is equal to minus 11. So already, straight off the bat, we have found a and or minus b. Okay, a fair bit trickier now than the next one. This is the pairs. So if you think back to your original pairs, they were alpha beta plus alpha gamma plus beta gamma. So now down for us, for our new pairs, it's going to be alpha plus 3 plus beta plus 3, alpha plus 3, gamma plus 3, beta plus 3, gamma plus 3. So they're all products. So when we multiply them out, this is what we get, and I'm going to let you enjoy all that fun doing that yourself. And then when we tidy up, this is what we get. And it's important we tidy this up. If you don't tidy this up, you'll never see this. So tidy it up, and you'll see you've got alpha beta plus alpha gamma plus beta gamma. So this was our sum of our pairs from earlier on. So this bit was equal to 3. And then here we had alpha plus beta plus gamma. This was your sum of your roots. Sorry, that one over here was the sum of the pairs, I should have said. This is the sum of the roots. That was 2. So you've got 3 plus 6 upon 2 plus 27, which is equal to 42. So the sum of the pairs, remember, is C over A. So C over A, remember your A is 1. So C over A is just 42. So C is equal to 42. So we're now just left to find our D. Okay, D, again, not easy because we've got the plus 3 in the bracket. You've got alpha plus 3, beta plus 3 upon gamma plus 3. Multiply that out and tidy up, you will get this. Alpha beta gamma plus 3, alpha beta plus alpha gamma plus beta gamma plus 9 times alpha plus beta plus gamma, and then plus 27. So there's a fair bit of work to do to get that. So just take your time and multiply it out. So I would multiply out maybe this bracket times this bracket, and I'll tidy up, and then multiply it by the alpha plus 3. So a lot of work to do. I've made that look as if it's straightforward. It's not. So just take your time and be very careful doing that. Once we have got it all multiplied out and tidied up as I had done on this line, it's easy to see. Alpha, beta, gamma, that was your triples, which we know was 4. Alpha, beta plus alpha, gamma plus beta, alpha, beta plus alpha, gamma plus beta, gamma was equal to 3. So this bit is just 3 times 3. This bit here, alpha plus beta plus gamma, that was your sum of your roots, which we knew was 2. So the whole thing becomes 4 plus 3 times 3 plus 9 times 2 plus a 27, which is 58. So again, minus d over a is 58. And remember your a is 1. So that means minus d equals 58, or d is equal to minus 58. So again, your equation, so this is just your a x cubed plus bx squared plus cx plus d is equal to 0. Sub in all your values for a, b, c, and d, and you get x cubed minus 11x squared plus 42x minus 58 equals 0. Okay, we're going to look for the second method, and again, this is definitely an easier way to do this one. The second method, then, we're going to look at the polynomial had roots of alpha, beta, gamma. We want to find what it would be if it had roots alpha plus 3, beta plus 3, gamma plus 3. So clearly the linear transformation to get from these three, is just add 3. So we're going to look at our method 2 now to do this. So in method 2, you're going to just let w equal x plus 3, and then again rearrange to make x a subject. X is equal to w minus 3. So we're going to sub into our equation 1, and here's my equation 1 written over here. So everywhere you see x, you replace it with w minus 3. So it's w minus 3 all cubed minus 2 upon w minus 3 squared plus 3 upon w minus 3 minus 4 is equal to 0. Okay, I've done a wee dot 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 because the life's too short, and just to show us we don't want, you can do this out in your own time, but when you multiply this out, you would get w cubed minus 11w squared plus 42w minus 58 equals 0. Now I've left out a significant bit of working out, which is not easy, but it is just multiplying out. If I were doing that, I would probably just draw out my Pascal's triangle to my 1, 3, and so on line, just to help me expand this really easily to get the coefficients, and I would just do each one of these out, and then we're good to go. So the final solution of this question is x cubed minus 11x squared plus 42x minus 58 equals 0. Okay, our last example says the quartic equation x to the power 4 minus 3x squared plus 15x plus 1 equals 0 has roots alpha, beta, gamma, delta. Find the equation with roots 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1, 2 delta plus 1. So you could do it using your first method from the last example. It would be awful, and you can see this is not a particularly nice question as it is. So go with the method I'm giving you here. If you look in your notes on Google Classroom, you'll see there's another version of this as well, just to show you it can be done another way. But really, one like this, where it's definitely a linear transformation, and it's the same. A key point is it's the same linear transformation. You can use this second method, and it is much easier. Okay, so to do this, you let w equal 2x plus 1. Rearrange to make x a subject, so x equals w minus 1 all over 2. And then you want to substitute that into the original equation, which was x to the 4 minus 3x cubed plus 15x plus 1 equals 0. Okay, so I've got an x to the 4, I've got w minus 2 all to the 4 minus 3 w minus 1 all over 2 to the 4. 3 times w minus 1 all over 2 to the power 3, 15 times w minus 1 all over 2, and then plus 1 equals 0. So this one is a key thing for me to decide how far I need to go in my Pascal's triangle. You could use your NCR to get your coefficients. Look how quick it is to draw your Pascal's triangle, and then this line gives you your coefficients for the power 4. This line gives my coefficients for the power 3. This line gives my coefficients to the power 2. So here, if we just look at this here, we have w minus 1. So the first term is going to be w to the power 4. Sorry, what I forgot to do here. They've got a 2 in the bottom line, so that's a half really. A half to the power 4 would be 1 over 16. So you have 1 over 16 upon, and then this is my expansion of w minus 1 all to the power 4. So the first term is going to be w to the power 4, and the coefficient of that is just 1. Next term is going to be it's going to be 4 times w cubed times minus 1, which is minus 4 w cubed. The next term is going to be 6 times w squared times brackets minus 1 squared. Minus 1 squared gives you plus 1, so it's plus 6w squared. Next term is going to be 4 times w times minus 1 cubed. Minus 1 cubed would be minus 1, so it's minus 4w. The last term is just going to be minus 1 to the power 4, which is positive 1. So I've done the expansion of that one, and you can see it's going to be 1 over 16 times this. Same idea, I'm not going to go through the next one. That's just going to be, this is expansion of w minus 1 cubed. This is expansion of w minus 1 to the power of 1 just, and then we've plus 1. And again, when we do the half cubed, you get 8. So that's why it's minus 3 times, when you do a half cubed, you get 1/8, I should say. Minus 3 times the half cubed. That's why this is minus 3 over 8, I should say. Okay, I've done all those expansions. When I did this first time, what I did stupidly was I multiplied everything, multiplied a 16 times this whole bracket, minus 3 over 8 times this whole bracket, 15 over 2 times this whole bracket, plus 1. And then I tidied up, and then I multiplied through. Much, much easier if you multiply through by 16 at this stage. So you multiply through by 16. The 0 times the 16 is just 0 still. 16 times 1 over 6, that just becomes 1. So 1 times that bracket, so I've just multiplied that out. 16 times this minus 3 over 8 becomes minus 6. And 16 times 15 over 2 becomes 120. 16 times 1 becomes 16. And this one, for some reason, people quite often forget about this one, the simplest of them all. The last numerical term needs to get multiplied by 16 as well. So you can see from here up, from this line to the next one, all you're doing is multiplying out. Then I've tidied up, and then I've got w to the power 4 minus 10w cubed plus 24w squared plus 98w minus 97 equals 0. Or you could write it back in terms of x. X to the power 4 minus 10x cubed plus 24x squared plus 98x minus 97 equals 0. That is us done with our notes on roots of polynomials for A-level further mathematics. So the questions you're able to do now, you're able to do exercise 4E, questions 1, 3, 5, and 7, and then the mixed exercise, questions 1, 2, 4, 8, 10, and 11. There are more questions available from another book, which I've uploaded onto Google Classroom as well. But if you will work through these and we're happy with these, I am happy that you are confident on these questions.